Hi everyone, welcome back to Pine Hollow out of Diagnostics. Back in the shop today is the 2002 Toyota 4Runner. This is the one that had the weak fuel pump causing a lean condition. So it drives great, but the customer complaint today is this check engine light has been on for a while with some EVAP codes. And just recently he says he's having trouble filling the tank, like the pump keeps shutting off. So there's some issue with the EVAP system. He said first he had a P0440 trouble code for a while. Then he got the P0441 in addition to the 440. He said he cleared the codes and then tried to fill the tank at a gas station. It couldn't fill the tank, so there's something going on. So let's do a little research on this Toyota EVAP system. We've done videos on these before. They're all very similar. And try to diagnose this problem efficiently. So I scanned the car for DTCs, and we have 3 codes stored: 440, 441, and 446. So, these codes can set for various reasons, and one document that's very handy to study before doing the diagnostics is this EVAP System Operation Information EG005-01. So we have the Lite type intrusive EVAP system. And here is the setup. So here's the fuel tank, there's the charcoal canister, and we have a whole bunch of hoses and valves, and there's the these X's, these are electric solenoids. So canister close valve, the purge valve, and this bypass VSV that's near the canister. Now, first thing I do is get the scanner and do some bidirectional controls. You want to make sure all these valves click nicely, that they're not stuck. Usually the ones under the hood are fine, but this one near the canister in the salt belt, these things just turn into clusters of rust. They seize solid mechanically and they don't click. So let's first do that with the scanner, see if the solenoids click, and take it from there. So we're using my favorite Thing Tool Pros today. Now these are getting discontinued, but I still haven't found a better scanner. Launch software, so any launch scanner will be able to do this exact procedure. And we'll log into ECM and actuation test. It'll load those up, and these will be the bidirectional controls. Okay, so here are the options. We have 12 bidirectional controls. We're interested in purge VSV, canister pressure control VSV, and the tank pressure bypass VSV. So 3 VSV. So let's start with the purge. We don't want to look at any data. And just click on. And you can hear it's hammering away under the hood. So the purge VSV is right here. This guy right here, see the green cap, purge coming in, and then that goes to the intake manifold. So we'll click off. Let's go to the next one. That would be this canister vent VSV, which draws fresh air from the air cleaner and then sends it back to the canister. So canister pressure control VSV. Okay. And on, off. That's this one clicking. On, off. So like I said, the ones under the hood are generally fine. Now, let's go to the third one, under the truck, and see if that one is clicking. Now, I do have a battery maintainer while we're doing our test with the key on. 13.5 volts on the Tornado. Let's dive into the truck. Alright, here we go. So I have the spare tire removed. Here's our charcoal canister. Here are all the lines coming to it. And right there, you can see is that bypass VSV. There's the electrical connection going to that. And it looks like, I suspected, a rusty pus sack. But let's see if it clicks. Okay, And we can even look at the fuel tank pressure while we do this, just to make sure the pressure sensor is okay, and see if it clicks. Alright, let's select vapor pressure in our data list. You can see, okay, here we go, 0.01 psi, so it's at atmosphere. So let's click on. Absolutely no click, and click off. I heard the quietest little pink. Let's see, on again, off. So that thing is seized solid. We need a new one of those. I guess we can try a standard motor products. They're about half the price of Toyota OEM. But does that explain why you can't fill the tank? Let's take a look at that document and see what's going on. I did notice that this hose here was detached from this nipple, just hanging out. What, is that important? Well, you would think everything's important. But the layout here is this hose attaches to this drain valve and goes up towards the filler neck. Now that is just a fresh air hose with a filter on the end of it, and this is a reference for the tops of these solenoids, I believe. See, there's a T, it goes right to here, and then it tees off and goes to the top of this one. So the tops of those diaphragms have atmosphere going to them. So it doesn't really matter if this is connected or not for testing, but we can leave that unplugged. Let's do a little more research. So on this diagram here, we determined that this little bypass valve is stuck. Now it could be stuck open or stuck closed. We don't know. Let's read how the system works and how, when you're filling the tank, where does the pressure go. So tank side, bypass VSV, check valve isolates tank pressure from the canister side. Canister side, we don't care about the echo. Except echo, there's a monitor sequence. So the 441 would set if the computer is basically trying to draw vacuum in the system. It closes the canister closed valve and then opens the bypass VSV, causing vacuum to the entire EVAP system. Then it turns on the purge, and if vacuum did not increase, or if the vacuum increased beyond the specified limit, the ECM judges the purge VSV and related components to be faulty. So the owner said that once this code set, he couldn't fill the tank anymore. That's, we'll keep that in mind. Then if that passes, it tests for actual leaks in the system. So 441, then 440, and 442. And we had 440, 441, and 446. Alright. So if it can draw vacuum, then it seals the system off. And if there's a very rapid, sharp increase, indicates there's a big hole, you get the 440. If there's a small increase, you get a small hole, 442. Alright. Now, vent control, CCV operation, P0446. That can be set by the CCV. When the vapor pressure rises to a specified point, ECM opens the CCV. Pressure will increase rapidly because of the air allowed into the system. No increase or an increase below specified rate indicates restriction on the air inlet side. Okay. Or 446 can also be caused by bypass VSV operation. This is a problem, but I don't think it explains why you can't fill the tank. So closes the bypass VSV action, blocks air from entering the tank side of the system. Pressure rise in the fuel tank side is no longer as great. Yes. So if that doesn't happen, there's no change in rate, then it sets the 446. Now, system outline. Go through here. I want to see when you're filling the tank, you know, how does this work? Let me find. Should be like tank onboard recovery operation. So for the early type, during refueling, low pressure above the diaphragm in the onboard recovery valve lifts, allowing fuel vapors into the charcoal canister. At the same time, the air drain valve opens and charcoal absorbs fuel vapors. So this is the same for both early and late systems, and it has nothing to do with the solenoids. Okay? As you can see, you're filling the tank, then the air wants to escape, and this ORVR opens up and lets fumes into the charcoal canister through a big pipe. And then, once the pressure builds up in the canister, it will automatically escape through the drain valve after being filtered through the charcoal. So, in our case, there's a problem either with this ORVR, you know, onboard recovery valve, I guess, and when the gas fuel level rises, it actually pushes the stopper up and your fuel stops flowing. So there's either a problem with this or with this. There can be two restrictions or something stuck in the lines. So how do we check for that? Well, what I want to do to check this valve first is just put the smoke machine on the purge valve, pressurize the system, and see if there's free flow coming out of this drain valve. Then we can pinch this hose off and see if there's any leaks in the system. You might as well check for leaks as well. That would be my next step. Holy crap, the smoke machine does not lie. What the heck is going on here? Is there a giant crack in the hose that's going to the charcoal canister? Wow. Let's see. That's insane. Let me turn the smoke machine off and we'll take a look at that. Alright, so I think this is making a little more sense. So I told the owner, hey, you should get your exhaust pipe fixed because of this. So you get hot exhaust gases blasting on the underside of the vehicle, and look what's happening. There is molten insulation on the pipes that's just melting off, and the plastic pipe that's coming, you know, this is the main vent pipe when you're filling up that's supposed to send those gases to the canister, and then the drain valve is going to dump them. Well, there's nothing being dumped because it's all escaping out of here. But still, would that explain why you can't fill the tank? It should. You would think that the pressure would just escape out of that melted hose. I mean, it was pouring out of there, but we actually don't know. Maybe the hose melted and pinched off on the tank side, and we're sending smoke through the canister and back through this hose to the tank, and it's leaking out of the hose, so, or the plastic pipe. So that's a variable. How do we determine if the if that hose is plugged off? Can we pressurize the tank side? Because there's no pressure on the tank side now. It's just in the canister. That's a mess. Well, let me inspect that plastic pipe. This is hilarious. So the flange broke off on both sides. Okay, but the tailpipe actually fits over the remains of the elbow. Kind of. It's rusty, but at least temporarily this will work in keeping the hot exhaust gases from causing carnage under the truck. So we can put a little clamp on here just to keep it in place, and then see why, you know, the onboard recovery valve is up there. You see this plastic pipe goes to here. So is that plugged up or not? Can we detach it from there and try to fill it? Or is there, is that not going to work? I disconnected the vent pipe from the canister, and bingo, this sucker melted and actually shut the whole pipe. Amazing. That's it. That explains all the customer complaints. So we need to fix this, and we need to replace that clicky valve, and then it should be good to go. So I'm going to take a picture of this and tell the owner to listen to the mechanic's recommendations when they tell him to fix the exhaust, because driving around, especially in the summer, with hot exhaust gases blasting at your plastic pipes and wires, that cannot lead to good consequences, as shown here. Alright, so we have to cut the this melted section of line out, and I guess just install a hose here. I think that'll be the easiest thing to do. So we'll cut right here. Perfect. And let me cut up here. We'll try to match up, you know, will that work? Or silicone pipe. I mean, this will be no pressure in here, just needs to be airtight. This will be a nice little souvenir for the owner. That's why you couldn't fill your tank, dude. Your exhaust just melted your vent pipe. Wow, I don't think I've ever seen that before. Customer complaint confirmed. So now I have, this is fuel stable and this is silicone, so whatever is easier to fit. Silicone is probably a little more stretchy. Oh yeah, that's gonna work perfect. So let me just install this on that vent pipe, and we'll put everything back together. I ordered a new Standard Motor Products solenoid for the canister. Should be good to go. Okay, final shot of the repair. There is the replacement silicone hose connecting the two plastic halves. And then I ordered the new valve. We'll put that in. But let's turn on the smoke machine and see if everything is leak tight. So the smoke should be coming in through out of this drain to the filter over there. Then we can squeeze this hose and see if the system builds pressure. Okay, smoke machine is pumping out the smoke. You can see the vent is coming out of there. So if we take this line off, yep, there it is. I plug that. Let's look in the scan data, see if the pressure is building in the tank. Okay, so back in the scanner, clear fault memory. Let's do that. Okay, and then in data, let's just look at the vapor pressure in the tank. Okay, excellent. Let's turn up the smoke machine. There's our vapor pressure, 0.27. And the ball is dropping, so I don't see any leaks yet. That might be the maximum pressure that's shown on the sensor. The smoke machine puts out probably 1 psi. And doesn't look like we have any leaks at all. Beautiful. So we'll shut that off. We can release our vent down here. Don't you see any smoke at all? So once we release this, we should see the pressure drop once it reaches below the 0.27 psi threshold. There we go. Simply beautiful. Okay, so this EVAP system is fixed once we install the new bypass solenoid, and the customer will have to take care of his exhaust tailpipe. I'm guessing just replace the tailpipe, but the flange is rotted off, so he'll deal with that later. Bonus footage on the Toyota 4Runner. Customer approved all the repairs, so we're replacing this bypass solenoid near the canister, and you can see the old one is a rusty piece of crap, and if you blow on the port, it's open. This replacement, standard motor product CP922, looks identical. Yes, it is made in China, but for non-critical components that are, you know, if it's readily available, it's half the price of an OEM, that's fine. It's fine. So try to blow through it. So it's supposed to be closed by default. Now if we hook up leads to it, just power and ground from my voltage supply, see if we can make this thing click. Clicks very nicely, and when it's on, you're supposed to be able to blow through it. Obviously this one is going to be completely seized up. So mechanically it's all swollen and it's not going to move. So we'll put this one in. Customer also approved a new tailpipe, so we'll get that done as well. Brand new tailpipe installed on the 4Runner, and it took a little bit of creativity to adapt it to the existing elbow because the flange rusted off of there too. So split flange, 2 bolts, and a pipe adapter that will basically go into here and into there. So let's start it up, check for leaks, and return this thing back to the customer. Nice and quiet. That's amazing. No leaks, no gaskets, almost no parts required. Sweet.